Greetings, this is Rescue Shuttle Control. We're very encouraged by the progress you've made over the last few sessions, and we can see that you're ready to gain some new knowledge and implement some more functionality in your systems. With the success that you've had in programming your keypad and implementing a security protocol, we're ready now to look at some more technologies. In particular, today we're going to be looking at visual displays. And this means that we'll be introducing both some new hardware and some new software ideas to you. First off, let's talk about the hardware. We're going to be learning how to work with what's called a 7-segment visual display. As you can see, we have one connected here to our hero, and I also have another 7-segment 4-digit display here not connected to anything, which we can use as a little bit of an example. When it's activated, the segments of this LED display will light up, and depending upon which segments are activated, we can display approximate representations of different numbers, letters, or symbols. And so we're going to learn about how to use this and actually do a little example of that today. The first thing that we probably need to know about is how to connect to this display. You can't see it on the front, but if I flip this display over to the back, you can see that there are 4 labeled inputs, 4 labeled pins that connect to the display. From the top here are CLK or clock, then DIO, digital output, VCC, and GND or ground. So the easiest ones to explain are VCC and ground because those are just the power supply that provide the energy to operate our display. VCC, for historical reasons, just stands for voltage common collector. All you really need to know is that's going to be our plus 5 volts power supply to the display. And we'll connect to that from the 5-volt supply pin on our hero. And corresponding to that, the negative side is just ground, and we'll connect that to ground on the hero as well. You'll notice that for today's session, we've disconnected everything from the breadboard. It's still sitting over there from our last session, but really today we're going to be focusing exclusively on connections between the hero and our 7-segment display. The point that I was just talking about was the bottom 2 pins here. The positive voltage is this red line, and it connects to the second from the bottom. And the black line here is the ground, and that connects to ground on the hero. So those two, the power circuits for our display, are pretty straightforward. The other two, clock on the top, will connect to a digital output on the hero and is used for controlling the refresh and update of the digital display, of the 7-segment display. And perhaps the most important one for us to understand is DIO, digital output, because it's going to be the digital connection to that pin that controls which of the segments of our display are lit up and which are dark, and controls what we're actually displaying on it. So that's a little overview of the connections to our 7-segment display. And you'll see when we start talking about the coding that what we have chosen to do is to connect our digital output line through this purple jumper to pin number 5 is connected to the purple wire, and that's going to be our digital output. And then this brown wire is connected to pin 6 on the hero, and that is our clock pin. And we'll see how that corresponds to the code that we write in just a little bit. But before we do that, we need to talk a little bit about the fundamentals of this 7-segment display and how we communicate with it. In order to illustrate that, I'm going to show you a little diagram here. The diagram here basically shows us why this is called a 7-segment display. Each character is consisting of these separate bars labeled A, B, C, D, E, F, and then the center cross piece here is G. And if we can instruct each of these segments to either be illuminated or dark, we can produce a representation of the character that we want. So for example, if I wanted to make a 0, I could illuminate A, F, E, D, C, and B, and I would get all the ones around the perimeter here lit up, but the center one would be dark, so that would look like a 0. If I wanted an 8, then I would illuminate all of them. A through G, all illuminated, would be an 8. And maybe if I wanted to make a 6, I could represent a 6 by illuminating A, F, E, D, C, and G and leave the other ones dark. So you get the general idea here. This is how we describe a 7-segment display. And what we need to sort of wrap our minds around is how I can communicate to the display which of those segments I want to be illuminated. So keep in mind that I have 7 separate displays that can be either on or off. And so that suggests that a binary function in which a 1 represented on and a 0 represented off might be a way of dealing with this. As a matter of fact, an 8-bit binary number has enough digits, and even with 1 left over, to control all of these separate segments with one of the bits representing each one of the segments. So I might, for example, imagine that the binary number corresponding to 1 would be 0000 with a 1 in the least significant position, so a 1 on the far right. And then the binary number corresponding to B would be binary 2, which would be 000010, and so on. All right, so this is our goal. Our goal is to go ahead and have a way of sending a digital number to the display through our digital output pin, and have that corresponding to a given segment or given set of segments being on or off. So we'll talk about that in a little bit more detail as we start to dive into the code. Before I dive into the code, however, there's a little preliminary that we need to take care of. Just as we had with the keypad, we're going to need some specialized code to access the 7-segment display. And that's code which has already been written for us and is available in the form of a library. As a part of our uplink to you today for today's session, we provided you with a zip file which contains the library necessary in order to access the 7-segment display. This TM1637 display is going to require the inclusion of the library that you see here at the top of our code. You could type this in manually, but you'd still have to make sure that your system has that library available. So just to remind you how you can go about and access that library, once you have acquired the zip file that we sent you in today's uplink, what you'll need to do is in your Arduino environment, under Sketch, you'll see where you can include libraries. Now, assuming that you haven't already brought in the zip file that we sent you, you can go ahead and specify add.zip library and add the file that we sent you. If you've already done that, and that library is already available to you, you'll be able to find it down here in the bottom under contributed libraries. And you can see there is TM1637, which means that I've already accessed the zip file and it's available as a contributed library. So if I include that library, you'll notice something about my code. When I include it, my code now has, at the top of it, include TM1637 display.h. And so that would be necessary to do if I hadn't already typed it in, which I already had. So that's redundant, and I'm going to go ahead and delete that because it's not necessary. But if you haven't already included the display library, you'll need to do that. The fact that this name, TM1637 display, shows up in orange is a clue to us that the system understands and recognizes this library reference, and we can go ahead and use it. All right. So we're ready now to move forward with some of the nitty-gritty of the code that's going to be used in order to display numbers and characters on our 7-segment display. Just as we did when we were using the keypad, we're going to use our library functions to create a display object, an object that allows us to control and manipulate our particular display here. So this object, which is of the form TM67 display, you can give any name you want. And so I decided to name my display my fabulous display. Fabulous display, in this case, is created by the call to this function right here, in which we've sent the numbers clock and digital I/O, which you can see we've defined up above here as being 6 and 5, which is consistent with the 2 pins that we chose to connect our display to on the hero at the beginning of today's discussion. So these numbers match what we did on the hero, so this should be ready to work for us as soon as we want to send commands and work with my fabulous display. All right, the next items in our code here are a couple of definitions of some sets of handy constants. And you'll remember that I was talking a few minutes ago about how we could represent all of the digits that represent whether segments are on or off with an 8-bit digital, an 8-bit binary number. And so according to that, consistent with that, we're going to define an 8-bit number. This is an unsigned 8-bit number. And we'll call this all on. So all on would be all ones. Every segment would be turned on. There are different ways of representing that binary number of all ones. You could write it as the decimal number 255, because 255 in decimal is the same as 8 ones in binary. Another convenient way to write that 8-bit binary number that's all ones, everything's turned on, is in base 16, also known to computer scientists as hexadecimal. And so in the hexadecimal system, instead of having to write 8 ones or 255, you can write it as FF. In writing code, we distinguish a hexadecimal number from a regular, say, decimal number by prefixing it with 0x. So 0x FF just means the hexadecimal number FF, or in other words, 255 decimal, or 111111111. So what we have here now is a constant number that has all of the bits turned on in each of these 4 entries. This will be handy for us because we can use this to just in a single fell swoop turn on all the segments if we want. Similarly, we have another constant here. We named this one all on, And so we'll name another array and we'll call it blank. And it's very similar, except that it now contains the hexadecimal number 00. And that's everything zeros. Everything's turned off. So these will be handy to us for quickly turning all of the segments on or turning all of the segments off. And we'll test that. Now, keep in mind that, as I was talking about before, when we want to turn on a particular character, we'll have to turn on different combinations of the segments. So for example, if I wanted to make the number 7, I'd want to turn on A, B, and C and leave all the other ones off. So how do I do that? Well, I construct a hexadecimal number or a binary number that has 1, 1, 1 in the positions of A, B, and C, and all the other ones 0. So I could figure out what that is. In decimal, that's the number 7. Or another way that I could do it is I could just simply take the number for A, the number for B, and the number for C, and I could stack them together in a bitwise OR. What that means is every place where there's a 1 continues to be a 1. And when I combine a 1 with a 0, it becomes a 1. So that's basically going to have the effect of turning on all of the segments corresponding to all 3 of those. So as a way of testing this and showing how it might work, we're going to create another constant that corresponds to spelling out the word done, D-O-N-E. It's a little bit funky because it's a little hard to write a good D or a good E with just a 7-segment display, but we'll do the best that we can with a kind of a mixture of upper and lower case. So you'll see here that we'll construct a D by ORing together segment B, segment C, segment D, E, and G. So if I show us what that looks like here, B is right here, C is right here, D is here, E is here, and G is here. So you can see that what we've done is made something that looks like a lowercase d. Likewise, you can see probably here is A, B, C, D, E, F, everything except G, and that's a large O or a large 0. C, E, G, so C, E, and G kind of looks like a lowercase n. And finally, A, D, E, F, G constructs for us an uppercase E. So by doing a bitwise OR, and that's what this single vertical bar here is doing for us, by doing a digital or a bitwise OR of these separate segments, we construct a binary number in each of these 4 slots corresponding to the letter D, uppercase O, the N, and the E. And so this will be a nice little thing that we can use when we're done with a task. We can ask the display to display the word done for us. And so that's why we're doing this as a little bit of practice to see how this might work. All right. I think we've covered the fundamentals of how we control and access the segments of our 7-segment display. And in this case, of course, we have 7 segments times 4 because we have 4 separate digits. And so that's the reason why our constant arrays here are 4 long, 1 for each of the digits of our display. All right, the code that we have to now work with at this point should be pretty simple. Shouldn't be too hard to figure out. Setup is very simple. All we're really doing, since we're not in this exercise working with the keypad or with the serial monitor or anything like that, we don't really have anything to initialize except our display. So the only thing we do in setup is just call clear on my fabulous display. So calling clear should set everything to dark. and we wait for a second and then move on with loop. So let's now take a look at what's happening in loop. One of the things that's essential to do if you want to get anything visible out of your display is to set the brightness to something other than 0. So we're now going to use set brightness on my fabulous display, set to the value of 7, which should give us a nice visible output. Next, as a test, we're going to try turning all the segments on. You'll remember that was achieved by setting everything to all on, as we defined up above. So we're going to use set segments, calling all on, and leave it that way for 2 seconds. So if this works as desired, we should see all the segments come on, all bright, for 2 seconds. And at the end of that, we call clear again, turn everything off, and wait for a second. So that's a good test, and that alone would be a good verification that we are doing what we think we're doing. But let's try another trick here. Let's try to do another function that could be very useful to us. What we're going to do is display a whole series of numbers. Now, you might think that in order to display numbers 1, 2, 3, 4, I'm going to have to laboriously construct them out of segments the way we did when we constructed the word done. But fortunately, we don't need to go to all that trouble because there already exists a library function that will take decimal numbers and turn them into segment codes for us right away. And so that's a nice convenience, and we're going to use that. So let's take a look at what's happening in this last part of the code. We start up a loop, a for loop. I starts at 0 and goes all the way up to 123. And so that's going to happen in this loop right here. And in this loop, basically what happens is after we set the value of I, we then call show number decimal, show number dec. And we put the number I in as an argument. So my fabulous display will show whatever the number I is at that moment. It'll flash by really quickly unless we put in a delay. So we'll put in a delay of 1/10 of a second. And then this should just repeat. Every 1/10 of a second, the number I should increase by 1, and the display should increase to show the next highest number. And we would expect this to continue all the way from 0 up to 123, and then the loop will terminate. At that point, we'll freeze for 2 seconds so we can see what the last number displayed was. Then after 2 seconds, we'll clear it back to blank again, wait for another 1 second, and then the last thing we'll do is we'll test our done. We'll set segments to our done code. And at this point, if I did nothing else, loop would just repeat this over and over and over again. I don't really want to do that right now. I just want to stop. And so instead of allowing loop to repeat over and over again, we put in a while one, which is a kind of a funny looking while loop because it doesn't seem to do anything. And that's exactly right. 1 is code for true. And so while here will always be true, which means that it will sit here and do nothing forever until we turn off the hero. So this is just one way of getting this to not do anything further, is it will just get stuck at while 1 and then stay there for good. You wouldn't have to do it this way. There are other ways to get the code to only execute something once. For example, if we wanted, we could have taken all this code and put it up into setup. But this works too. So we'll just run one pass through loop and then hang up when we get to while, and that should be the end of our interesting function. All right. With that all presented, I think we're ready to go ahead, check our code, and see if it operates as intended. As usual, I'll go ahead first off and check by compiling the code to see if it gives any errors. It says it's done compiling. and there don't appear to be any syntax errors, so maybe we've done it correctly. So the next thing that we're going to do is we're going to upload the code to the hero. And then we're going to watch, because unlike the code that we were using with the keypad, it's not going to be waiting for us to input anything. It's just going to jump right in and start doing its thing. So we should watch the display and see whether it goes through the expected sequence of displaying all bars on and then showing us the incrementing numbers until finally it's done, and then it shows done. So let's go ahead, give it a shot, and see how it works. Uploading now. And we're watching to see what happens. And we have all segments on. Now it's off. Now we're counting. So we're going up through the decimal numbers, up 40, 50, 60. We're expecting this to go up and freeze at 123. So there's 110, 120, 123. Okay, it was on for 2 seconds and then it went to done. So it looks as though we wired and programmed it correctly. This will be a good system for you to duplicate, perhaps modify to your liking, and experiment a little bit to see that you understand how to correctly code and how to correctly control this 7-segment display. And in the process, you might want to experiment a little bit with creating your own characters by thinking about how to construct the necessary 8-bit digits to produce what you want on the display. So that is a good milestone for us to stop on right now. And next time we'll work on expanding our range of functions and knowledge even more. So for now, remember, build everything and invent safe.